Hello students, welcome back to the online class. So in the previous class we were discussing about the fluid mechanics concept, and we have come across a new topic in that is called viscosity or viscous force in the liquid. So some of the examples also I have given you people, like how to understand in order to get to know about the viscous in day-to-day life example, and later on some of the purposes, in practical purposes, how it affects all those things we have discussed, like a machine get jammed, coal tar will be heated up before it's used, etc. Right? So today what we do is we'll discuss much about that topic under fluid mechanics concept. So let us begin. So today's topic is something called velocity gradient. Okay, velocity gradient, which comes under viscosity concept. Velocity gradient given by equation dv by dx. Okay. So what is velocity gradient? So question. See, of course we know liquids will have their own tendency. Okay. The property by virtue of which there will be a resistive force in between what layers of the liquid, correct? That is what called viscous force. So this viscous force, when it is exerted in between the layers, okay, that means tangential force, it is mentioned right in the definitions. So because of that particular what is that called, viscous force, so what we can understand from that is different layers. Okay, the layer which is attached to the surface which flows, which will be having more viscous force. Slightly upper layer, like that, speed differs. So these layers will move with one particular speed, right? So to understand that, we have the concept called velocity gradient. So what is velocity gradient? That is nothing but, definition I will write down: the rate of change of velocity. Okay, velocity means v. What is dv? That means small. Just v means velocity expression. dv means what? Little amount. Okay, delta or dv, like that we use usually in science. So rate of change of velocity with the distance. Okay, with distance. Distance means, yes, to what extent? That x is there, right? X means nothing but separation, distance we usually take. What is dx here? That means little amount. That is what the meaning. Okay. So these things, that means rate of change of velocity with distance perpendicular to the direction of propagation. Direction of propagation is called velocity gradient. Velocity gradient. Okay, in short I am writing v dot g, I am writing dv by dx. In words if you write, it is well and good. Okay, in notes, in words you write velocity gradient equal dv by dx. So this is the definition. Have a look. Very simple definition it is. The rate of change of velocity with distance perpendicular to direction of flow is called velocity gradient. So what is the SI unit of velocity gradient? Let us see. SI unit, velocity. Though it is bigger velocity, smaller velocity, velocity always has got its own what? SI unit, correct? dv by dx. What is the SI unit of velocity? Numerator, meter per second. Denominator, x means what? Separation, distance. Dx means small separation. So what is that? Dx means meter. So what is this? Per second. Dimensional formula, of course, in second chapter you have learnt about it. Per second, t minus 1. See? Dimensional formula. So this is all about what? All about velocity gradient, which is one of the factor which affects the viscous force of given liquid. So what is velocity gradient? The rate of change of velocity with the distance perpendicular to the direction of propagation. Okay, rate of change of velocity with the distance perpendicular to direction of propagation. That means if liquid is moving like this, okay, or towards this direction, this rate of change of velocity with respect to distance is there, right? For different layers. That is what called velocity gradient. Hope this is understandable and clear for you people, okay? Now, let us go for factors on which that viscous force of different layers depends. Let us see. Okay. Next one, that is factors on which viscous force of different layer depends in liquid. Okay. About what is viscosity, what is viscous force, we discussed definition over. Thereafter, what is the practical application, what is the practical difficulties. All those things we discussed in the earlier class. Why? Because that gives us more knowledge. More easily we can understand what is this viscous force. Right now we are getting into the depth. That means what is the science behind it? What are the factors on which it depends? What are the way of understanding that in mathematical way? So that's what we are discussing now. Okay. So factors on which viscous force on of different layers depends in the liquid. Okay. So the factors of viscous force is actually explained by Newton. Okay. So Newton, scientist. According, you have to write as it is. Okay, like how I have mentioned on the board. Neatly you have to write full sentence along with. Okay, according to Newton, viscous force depends, or like this we can take, like instead of writing depends, we can write viscous force between, hope this is visible for you, yes, layers, viscous force between layers is directly proportional to yes, first one, area of liquid layer, second one, velocity gradient. Okay, area of the layer, velocity gradient. So area of the liquid layer or area of the layer is given by A, velocity gradient, of course dv by dx. So how it can be written in terms of equation now? So F is proportional to A into dv by dx according to the definition. This is the formula. Neatly you have to write. Okay. So proportionality is there, but what we require, always we have to go for. So proportionality means it is uncertain. We require what? We require a standard way of representing it with equal symbol, correct? Equality symbol. So for that we require a constant. That constant is minus eta a dv by dx. This is the final formula. So what is eta? You already know. That is coefficient of viscosity. Correct? So I repeat once again. For examination it can be asked, factors on which viscous force of different layers depends in liquid. If it is asked, means how to explain this one? According to Newton, the viscous force between layers of the liquid is directly proportional to area of the liquid layer, or area of the liquid, or area of the layer. Next, velocity gradient. So finally, F is proportional to A into dV by dx. With equality symbol, how you are supposed to write? F is equal to minus eta A dV by dx. In this way you have to write. And you have to mention one thing. What is that? Here, negative sign is there, correct? So what does this negative layer suggest is, you have to write, okay, in sentence, write down that negative sign indicates that viscosity decreases with increase of velocity gradient. Correct? I repeat, negative sign indicates viscosity decreases with increase in velocity gradient. Yes, this part is finished. That is how the explanation has to be given. So what is viscosity? How generally we can understand that by taking some of the example like ghee, oil, water, something like that. Yes, of course, easily you are able to understand. And later on, some of the practical purposes, practical scenarios, observations also we discussed in the previous video class. Now, scientifically we are actually approaching regarding the viscosity concept. Yes, fine. So finally, yes, we have discussed about some of the factors about viscosity, and one of the, yes, factors, that means how it depends. Okay? Yes, that's all about the factors on which viscosity depends. Fine. Now, let us go for, so what is viscous force, what is viscosity, we have discussed in the previous class. Right now, here eta means, I told you people, coefficient of viscosity, correct? So what is coefficient of viscosity? Let us see now. So coefficient means something which has got ratios, correct? That means coefficient of viscosity. So what is coefficient of viscosity? Very important definition for examination point of view. Okay. So what is coefficient of viscosity? Let us see. So we know that viscous force is nothing but equal to n eta A dV by dx. We require what is eta, like this. Okay. So now, that means I am explaining what is eta, like this. If area of the liquid layer is equal to 1 unit, and unit in the sense meter square, yes, of course, SI unit is there, but just basically speaking, velocity gradient dV by dx, if this one is also 1 unit, means apply in the equation. Now how does it look? F equal to minus eta 1 into 1, correct? So finally, magnitude of, that means, right, magnitude means we are not considering the negative sign. Just we are considering what is F. So the viscous force is directly proportional to viscosity of the liquid. This is how we get. Okay. Magnitude means only we are taking the quantity. Okay. Magnitude of viscous force. So right now, what is viscosity? Eta equal to viscous force, correct? When it is possible, when area of the layer is how much? 1 unit, and velocity gradient is also 1 unit. Correct? So how to define now? Yes, it is a force per unit area acting between two layers having unit velocity gradient. That is it. Okay. So what is this? Eta equal to F divided by what? This is general formula I am writing to make you understand. If you want eta, what happens? Take this one to the left hand side. So, into dV by dx, correct? This is the ultimate formula. This is just for your understanding. Where A and dV by dx, if it is made 1, so how we can understand now? So it is the coefficient of viscosity is actually defined as, it is a force, viscous force or force per unit area of a layer of the liquid and unit velocity gradient. So I told the definition. Hope you are able to recall it. So I can explain once again. So viscosity means definition, everything is done. Coefficient of viscosity means it's a standard way of understanding because it's a constant. So what is coefficient of viscosity? Yes, how to understand? Like this you have to rearrange. So what is eta we will get? So it is a force per unit area of the layer of liquid and unit velocity gradient. What type of force is a viscous force, correct? So write neatly as it is, okay? Like after writing the equations, you are supposed to write what? Coefficient of viscosity is the viscous force per unit area of the layer of the liquid and unit velocity gradient. So that is how we can explain it. Force per unit area acting where? Acting between two layers, like that you can write down. Okay. Fine. So this is about coefficient of viscosity concept. Okay. Fine. So now, what is the SI unit? Let us see. Okay. SI unit. Here, I will show you here. What is SI unit? Force means Newton. Divided by area means meter square. dV by dx means already we discussed that time, correct? What is that? Per second, correct? So take this to numerator. Here I will write in this box, students. So Newton as it is, meter square goes up, that means per meter square, second goes up like this. So Newton second per meter square is the SI unit. Write down neatly. SI unit of coefficient of viscosity is, hope you understood how to get the SI units usually. So I have just applied, by looking at the equation only, I substituted the SI unit of force, area and velocity gradient. So got Newton second per meter square is the SI units. For example, exams and all, it is important, okay? Take down neatly. Fine. Write neatly, legibly, okay? Step by step. Definition of coefficient of viscosity I told you already. Write the definition neatly as I said. Very, very important it is. Fine. So now I will erase this entire thing what I have written on the board. Yes. Fine. Now let us move on. So we got to know that, of course, if you are able to study regarding the force, viscosity, coefficient of viscosity, all these things, fine, a slight easily understandable kind of things we have discussed. Okay, these are not much, complicated things. And now let us discuss about one of the scientists. Okay, he has given one of the law. What is that law is? Imagine that a very deep well is there and you are going to jump in because you are very good at swimming. Imagine there is some object at the base of the well and you are going to jump. Okay, so you'll jump, you'll deep diving thing you will be doing. So you'll go inside that, you'll pick some object, whatever it was, fell inside, and you'll come back, whatever. Now imagine 20 feet was the depth of the well. Fine. Imagine in air medium, that means out of water, air medium like this. From 20 feet you jump to the ground. From 20 feet you jump to the ground. Your acceleration due to gravity will be 9.8 meter per second. In very high speed you will come down and you will hit the ground, correct? Similarly, when you jump inside that water, do you think with the same speed you will go down to the base of the well? Okay, think like that. Of course it is not possible because density of the medium has changed, and of course, so imagine that if you jump on liquid surface all of a sudden, suddenly you won't sink inside. Liquid also will give you some opposite force. For every action, equal and opposite reaction is there. That's how the ship floats. Okay, that is actually initially given by Archimedes, one of the scientists. Understanding, right? So that I will discuss after one of the law, scientist law. So just give you the example, okay? Like how ship floats on sea surface or water surface. That is because of the buoyancy. Buoyancy in the sense, all those things I will write later. Buoyancy in the means upward thrust or upward force, which is given by the water or liquid. How much force you apply, that much opposite reaction it will give. By doing what? By displacing that amount of water. So if you are having 10 kg, if you are having any object of 10 kg, if you just made that to fall on water surface, water will displace 10 kg amount of water. Okay, so that is how, and water will try to push it up. It depends on the shape of that particular object as well. Understanding, right? So if it is actually having a sharp cut edges, something like that, it will sink. If it is having a curvature kind of shape, means of course it will float. Like ship, boat, all these things will float, right? It won't sink inside. Whereas human body will sink easily, correct? That's all because of the shape. Understanding, right? So let us get back to the viscosity concept. We'll discuss about one of the scientists has given one law. So what is that law? Let us see. It is given by, I will write like a question, okay? State and explain. State and explain. Stokes law. So Stokes law, why I have told is, I told you right, suppose you jump from 20 feet in air in a fast way, you'll hit the ground, whereas if you jump inside well, which is of water, same 20 feet if you want to travel means you will take slightly extra time, slowly you will move inside, correct? That's all because of something called viscosity, correct? Water will exert viscous force on you.